This course outlines the approach most commonly recommended for identifying and correcting ergonomic problems. It provides basic information that will be useful for employers, workers, and others in designing effective programs to prevent work-related musculoskeletal disorders, WMSDs, in an industrial environment. This course addresses one of the most prevalent and costly safety and health problems in the modern workplace and provides useful information for putting a program into place. Poor work posture and workstation arrangement in an industrial work environment can mean the difference between a job that is enjoyable and productive and one that is a nightmare for the employee and unproductive for the employer. In this training program, we're going to discuss only one part of a good industrial safety program. It's called ergonomics. Ergonomics is nothing new. There have been a number of improvements and advancements in the study of ergonomics in recent years. In November of 2000, the Occupational Safety and Health Administration, or OSHA, released its first ergonomics standard. Your organization has taken steps to comply with the rules and regulations put forth in that standard, and it's up to you to follow your company's procedures and take an active role in protecting yourself from ergonomic injuries. Now let's take a look at this important topic, because everyone needs to know the hazards associated with ergonomics. With this information, you'll be armed with the knowledge needed to prevent ergonomic-related injuries. In short, this program will help you control your safety at work much better. A substantial number of American industrial workers may be at risk of developing some type of ergonomic or musculoskeletal disorder due to their exposure to ergonomic hazards in the workplace. In recent years, there has been a significant increase in the number of occupational ergonomic disorders reported. This poses a serious problem for exposed workers and their employers. What is ergonomics? Ergonomics is the science of fitting workplace conditions and job demands to the capabilities of the working population. Effective and successful fits assure high productivity, avoidance of illness and injury risks, and increased satisfaction among the workforce. Although the scope of ergonomics is much broader, the term in this course refers to assessing those work-related factors that may pose a risk of musculoskeletal disorders and recommendations to alleviate them. These same principles are factored into almost everything we use today: automobiles, kitchen appliances, tools, and workplace machinery. How does compatibility between the work environment and people influence safety? Since accident statistics have been maintained, we've learned that most causes of poor productivity, poor quality, illness, and accidents are due to human error. Equipment, objects, and environmental characteristics influence human behavior. Optimal performance is obtained when products, equipment, workstations, and work methods are designed while keeping human capabilities and limitations in consideration. Close harmony between the work environment and people is the goal. There are many things we can do to prevent ergonomic-related injuries. That's what this program is all about, empowering you with the knowledge and direction needed to make your job safer without injury. Step 1. Problem recognition. To find ergonomic problems, we must look for signs of potential musculoskeletal injuries in the workplace, such as frequent worker reports of aches and pains, or job tasks that require repetitive, forceful exertions. Step 2. Management commitment. Showing commitment in addressing possible problems and encouraging worker involvement in problem-solving activities is essential. Without the dedication of company resources, the program will be ineffective. Step 3. Training. Training is critical. Training ensures that the program will run effectively and serves to educate employees at all levels to the benefits of the program. Step 4. Gathering data. Proper data allows us to identify jobs or work conditions that are most problematic. This is accomplished using sources such as injury and illness logs, medical records, and job analyses. Step 5. Identifying effective controls. It's important to identify controls for tasks that pose a risk of musculoskeletal injury. After controls have been implemented, we must evaluate these approaches to see if they have reduced or eliminated the problem. Step 6. Establishing healthcare management. Healthcare management is needed to emphasize the importance of early detection and treatment of musculoskeletal disorders for preventing impairment and disability. Step 7. Minimizing known risk factors. For musculoskeletal disorders, it is important when planning new work processes and operations to build good design into the workplace than to redesign or retrofit later. Step 8. Controlling workplace hazards. This can take many forms. Ergonomics and industrial hygiene are closely related. Once workplace hazards are known, these hazards must be controlled through the use of engineering controls, administrative controls, or the issuance of personal protective equipment, PPE. What are clues to ergonomic problems in an industrial environment as a real or potential workplace problem? Some signs are obvious, while others are more subtle. The first step is to investigate. You can start by looking at OSHA Form 200 logs or workers' compensation claims. These records show ergonomic problems such as carpal tunnel syndrome, tendinitis, tenosynovitis, epicondylitis, low back pain, hand pain, elbow soreness, shoulder discomfort. Next, take note of certain jobs or work conditions cause worker complaints of undue strain, localized fatigue, discomfort, or pain that does not go away after overnight rest. Workers who visit healthcare providers frequently with complaints of physical aches and pains related to certain types of work assignments are a good indication that ergonomic risk factors may be present. Finally, check out job tasks that involve activities such as repetitive and forceful exertions, frequent heavy or overhead lifts, awkward work positions, or use of vibrating equipment. Training ensures that you are well informed about the hazards so you can actively participate in identifying and controlling exposures. Open and frank interactions between trainers and trainees, especially those in affected jobs, are especially important. Employees know their own jobs better than anyone else and often are the source of good ideas for ways to improve them. As a minimum, employees must be given an opportunity to discuss ergonomic problems in their jobs as they see them and engage in relevant problem-solving exercises during the training. Once a decision has been made to initiate an ergonomics program, a necessary step is to gather information to determine the scope and characteristics of the problems or potential problems. A variety of techniques and tools have been used. Many provide the basis for developing solutions to identified problems. Health and medical indicators, follow-up of worker hazard reports, reviewing OSHA logs, review non-OSHA records, conducting symptom surveys, periodic medical examinations, identifying risk factors in jobs, screening jobs for risk factors, performing job analyses, setting improvement priorities. A three-tier hierarchy of controls is widely accepted as an intervention strategy for controlling workplace hazards, including ergonomic hazards. The three tiers are as follows: engineering controls, reducing or eliminating potentially hazardous conditions; administrative controls, changes in work practices and management policies; use of personal protective equipment, PPE. Engineering controls are the preferred approach to prevent and control ergonomic problems in the workplace. They involve designing the job to take account of the capabilities and limitations of the workforce. In other words, engineer out the problem. A good match, meaning that the job demands pose no undue stress and strain to the working population as a whole, helps ensure a safe work situation. Examples of engineering controls include changing the way materials, parts, and products can be transported, such as using mechanical assist devices to relieve heavy load lifting and carrying tasks, or slotted handholds in packages requiring manual handling. changing the process or product to reduce exposures to risk factors, changing the way parts, tools, and materials are to be manipulated. Examples include using fixtures, clamps, vice grips, etc., to hold workpieces to relieve the need for awkward hand and arm positions, or using suspending tools to reduce weight and allow easier access. Changing tool designs. For example, pistol handle grips for knives to reduce wrist-bending postures required by straight-handle knives, or squeeze grip actuated screwdrivers to replace finger trigger actuated screwdrivers. Changes in materials and fasteners. For example, lighter weight packaging materials to reduce lifting loads. Changing assembly access and sequence. For example, removing physical and visual obstructions when assembling components to reduce awkward postures or static exertions. Administrative controls are work practices and policies intended to reduce or prevent exposures to ergonomic risk factors. Administrative controls are often helpful as temporary measures until engineering controls can be implemented or when engineering controls are not technically feasible. Since administrative controls do not eliminate hazards, it's important that the practices and policies are followed. Examples of administrative controls include reducing shift length or eliminating overtime, rotating workers through several jobs with different physical demands to reduce the stress on limbs and body regions. This is also known as job rotation. Broadening or varying the job content to offset certain risk factors. For example, repetitive motions, static and awkward postures. This is also known as job enlargement. Adjusting the work pace to relieve repetitive motion risks and give the worker more control of the work process. This is also known as optimal pacing. Scheduling more breaks to allow for rest and recovery. Training employees in the recognition of risk factors for ergonomic stressors and instruction in work practices that can ease the task demands or burden. One of the most controversial questions in the prevention of ergonomic-related stressors is whether the use of personal protective equipment worn or used by the employee is effective. In the field of occupational safety and health, PPE generally provides a barrier between the worker and the hazard source. Although PPE may, in some situations, reduce the duration, frequency, or intensity of exposure, evidence of their effectiveness in injury reduction is inconclusive. In some instances, they may decrease one exposure but increase another because the worker has to fight the device to perform his or her work. Examples of personal protective equipment that may or may not be used at your facility include wrist supports, back belts, vibration attenuating gloves, and other types of ergonomic PPE. What's the bottom line? Be sure you know your company's policies and procedures and follow them. In general, healthcare management emphasizes the prevention of impairment and disability through early detection, prompt treatment, and timely recovery. Medical management is a group effort. Responsibilities fall on employers, employees, and healthcare providers. Your employer can encourage early evaluation by a healthcare provider by taking the following steps: providing hazard recognition training, encouraging early symptom reporting, giving healthcare providers the opportunity to become familiar with jobs and job tasks, accommodating employees who have functional limitations, ensuring employee confidentiality during assessments. Employees may be faced with conflicting job demands or requirements. Safe work practices or rules may conflict with pressures or incentives to be more productive. Where workplace conflicts occur, employees should notify management and seek a productive and safe solution. Always follow safe work practices or rules. Employees should participate in the healthcare management process by following applicable workplace safety and health rules, following work practice procedures related to their jobs, reporting early signs and symptoms of ergonomic-related stressors. Healthcare providers are critical to the success of an ergonomic program. Occupational health facilities tend to know more about work-related injuries than your general physician. The healthcare provider is responsible for the following: reviewing information and materials related to job activities, ensuring employee privacy and confidentiality to the fullest extent permitted by law, evaluating symptomatic employees, including medical histories with a complete description of symptoms, description of work activities as reported by the employees, physical examinations appropriate to the presenting symptoms, examinations to follow up symptomatic employees and document symptom improvements or resolutions. Proactive approaches to workplace ergonomics programs emphasize prevention of ergonomic stressors through recognizing, anticipating, and reducing risk factors in the planning stages of new work processes. To this point, we've discussed reactive approaches to dealing with workplace ergonomic problems. The steps discussed offer a plan for identifying ergonomic problems and job risk factors linked to them, and selecting and implementing measures for controlling them. In contrast, proactive approaches are geared to preventing these kinds of problems from developing in the first place. Ergonomic issues should be identified and resolved in the planning process. In addition, general ergonomic knowledge learned from an ongoing ergonomics program can be used to build a more prevention-oriented approach. Management commitment and employee involvement in planning activities are essential. For example, management can set policy to require ergonomic considerations for any equipment to be purchased, and production employees can offer ideas on the basis of their past experiences for alleviating potential problems. Once an ergonomic program is implemented, how do we ensure that it remains effective? We control workplace ergonomic stressors through a variety of ways, such as regular program reviews, conducting periodic workplace audits, frequent employee surveys, employee participation in the program, ongoing training at all levels, healthcare provider feedback. Now let's discuss some specific ergonomic risk factors and things you can do to make your daily work safer and more enjoyable. Occupational risk factors generally fall into 4 different categories of risks. These include 1. Inappropriate force, internal or external. 2. Inappropriate posture, extreme twisting or bending. 3. Inappropriate repetition, causing muscle group overexertion. 4. Insufficient rest, causing muscle group overexertion. Your personal ability to do a job can depend on a variety of factors. This is the basis of ergonomics in the workplace. Since we can't often change you, we must ensure the work environment is adaptable to you. Personal risk factors that may vary between people include age, gender, attitude, training, strength, work method, general health condition, body shape and size. Job risk factors are numerous. If you stop and consider the variety of stressors on your body during the conduct of work, you can see that it is extensive. Some of these stressors may be beneficial if controlled. In other words, work can translate into a better word if the work is safety controlled. Control is the key. Let's look at some specific risk factors associated with individual jobs. The weight of loads you carry every day during work can cause muscle strain and possibly back problems. If possible, work assist should be used, such as carts or lifts. The location and size of the load may be adjustable. Generally, you shouldn't be lifting above the shoulders or reaching below the knees. Also, dividing the load into smaller groups reduces stress on your back. The frequency of the task you perform during the workday should be varied to prevent overexertion of specific muscle groups. If you remember, we discussed a term called job enlargement. This is where you vary the types of work you do during the workday. How long can you perform a specific type work? The duration and pace, how fast you perform, should be matched with your preference and ability. Adjustability is the key here. The stability of the load is very important. For example, if you're carrying a box and the load inside the box shifts, this may cause back injury or make your feet slip. Consider how you could better stabilize the load for your safety, such as by using a smaller box or cushioning inside the box to prevent load shifting. How do you carry loads at work? The grip or coupling between you and the load is very important. A different container often helps you better carry or move an object. Do you need to go to the work? Is there a way to bring the work to you? How much walking do you do during the day? If you can bring the work to you, this will save time and effort, and may just be more productive for the company too. Coordinate with your supervisor ways you can save yourself work. For example, instead of having copy paper delivered to the front office, maybe the delivery person can bring it to the copy machine instead. Pushing a hand truck 100 more feet is easier than you having to go and carry a box to the source of its use. Can you reduce the reach distances required to perform your work? Moving bins, shelves, or other frequently used items closer will reduce strain on your back and in your arms. How is your workstation arranged? Do you face your work, or do you have to perform unnecessary twisting to accomplish work? If your work is symmetrical or directly facing you, this is better for your body. Talk with your supervisor about modifications that may be needed to your workstation. Ergonomic risk factors may be present even when you're not moving. This may be causing you ergonomic problems. For example, if you're sitting in a chair and you have to control your stability with your legs, this is causing static pressure on your leg and back muscles. Your elbows and chair should be providing support. The right floor surface can also help minimize stress. The floor surface should enable you to work comfortably and ensure a stable work environment. Reducing static pressure on your body in a standing or sitting position is very important. Do you climb work platforms or stairs during the course of work? If you can't eliminate the need to climb, can you combine tasks or jobs to limit the number of times you climb during the workday? This will add up over time. Ask your supervisor and coworkers for ideas. If you twist your hips a great deal during work, it can cause back strain. Generally speaking, you shouldn't twist uncomfortably during the course of work. Try to arrange your work to be symmetrical with your normal work position. Torso flexion of less than 45 degrees is the best for work. Think about ways you can arrange your work environment to reduce twisting your hips. If you bend your hips a great deal during work, it can cause back strain. Generally speaking, you shouldn't reach below your knees or lift above your shoulders. Think about ways you can arrange your work environment to reduce bending and twisting. The temperature of your work environment should be comfortable for you. While some jobs require work in a hot or cold environment, every effort should be made to reduce the hazards associated with these environments. Lighting in the work environment can be divided into 4 general groups: general lighting, direct lighting, task lighting, and natural lighting. General lighting refers to the overall lighting in the workplace. Direct lighting refers to workstation lighting. Task lighting is additional lighting used to perform certain tasks. Natural lighting refers to light from the sun. Discuss lighting issues with your supervisor. You shouldn't have to strain to see or perform your work. The lighting in the facility should be sufficient to ensure safety. Vibration can be very damaging to your body. Reducing noise levels and damping vibration is critically important. If your work environment has excessive noise or vibration, ensure you discuss possible solutions with your supervisor. Workstations should be adjustable, enabling both large and small persons to fit comfortably and reach materials easily. Keeping objects within arm's reach is a good rule to follow. Work materials and tools should be located in front of the worker to reduce twisting motions. Sufficient workspace should be provided to enable the whole body to turn. Ensure the worker avoids static loads and fixed work postures. Workstations should be designed for adjustable work surfaces, range of motion of the worker, field of vision of the worker, comfortable ranges of motion, adequate support to back and legs, frequency of motions required, various reach heights, various reach distances, mechanical or powered assists, suspension devices for tools. Workstation design should reduce force and job accomplishment, the duration of a specific task, trauma to reduce leg trauma. The bottom line is that all workers must be able to be accommodated by the workstation. General safety issues such as protective guards, PPE, proper tools, etc. must also be considered. The bottom line is, don't design for the average person. Don't design for yourself. Design for a range. Design for adjustability. It is important that repetitive hand and wrist tasks be carefully studied to implement ergonomic improvements. Hand and wrist problems account for a significant portion of work-related musculoskeletal disorders. Here are some ideas that may be useful in reducing trauma to the hand and wrists. Designed to reduce extreme motion of the wrist, the number of repetitions per shift, the force on the wrist and hands, the pressure on the wrist and hands, the weight and size of objects handled. Designed to avoid inward-outward rotation of the forearm, non-neutral positions of the wrist, tools that create pressure on the palm, tools which can obstruct blood flow, tools that damage nerve function, repeated pounding with the palm, repetitive pressing with the fingertips, forceful pressing with the fingertips, reaching more than 15 inches from body, poorly or improperly designed tools. It is important that lifting and lowering tasks also be carefully studied to implement ergonomic improvements. These types of tasks account for a significant portion of back injuries in the workplace. Here are some ideas that may be useful in reducing lifting and lowering task injuries. Designed to optimize or reduce material flow through the workplace, manual lifting of materials, inadequate shipping and receiving facilities, inadequate storage facilities, inadequate clearances in aisle and access areas, the need to lift or lower manually, the lifting distance from the body. It is important that pushing or pulling tasks also be carefully studied to implement ergonomic improvements. Eliminate pushing or pulling by using conveyors, powered and non-powered, powered trucks, lift tables, slides or chutes. Reduce the force required to push or pull by reducing size and/or weight of load, using four-wheel trucks or dollies, using non-powered conveyors. Require that hand trucks or dollies have periodic lubrication of bearings, adequate maintenance. Require that floor surfaces be properly maintained, free of holes and bumps, treated to reduce friction. Reduce the distance of the push or pull by moving work closer to work production areas, eliminating unnecessary materials handling. Optimize the technique of the push or pull by providing variable height handles, replacing a pull with a push if possible, using ramps with less than 10% slope. For the purposes of industrial ergonomics, we separate brakes into two different categories: active brakes and micro brakes. When you work in one position for a long period of time, blood flow is restricted. Your body needs activity. You should change your work position at least every 15 minutes. Active breaks should be taken at least every 45 minutes. Moving around and stretching periodically is essential. This allows your muscles and bones to move in a wider range of motion. Body strengthening and exercise. When we talk about lifestyle changes, we're just making recommendations that have proven to help people avoid injury and illness. Lifestyle changes refer to things you can do to reduce ergonomic hazards from a personal standpoint. Stretching and strengthening active muscles promotes relaxation. Relaxation is as important for prevention of ergonomic-related problems as it is for general well-being. take a new, more active role in promoting your general fitness both at and away from work. If you don't exercise regularly, get clearance from a physician to add walking, bicycling, swimming, or other exercise to your weekly schedule, at least 3 separate days. Diet and personal habits. Cut down on stimulants like coffee, sweets, or nicotine, and spread healthy snacks and water intake throughout the day. Keep water at your desk, as it makes for a smart micro or mini break. Remember that the first symptom of dehydration is fatigue, not thirst. Fruit and vegetable snacks prevent mid-morning and mid-afternoon blood sugar drops. These dips can affect alertness, mood, productivity, and decision-making. A diet emphasizing complex carbohydrates, reliable sleeping patterns, and time for yourself can do wonders for work performance and your well-being. The objective of the safety program is to make sure that all employees fully understand their job responsibilities in preventing accidents. This includes how to prevent ergonomic-related disorders in industrial work situations. Take a look at your work area and make suggestions on how to improve the ergonomics of performing your job. Safety is your responsibility. The company can provide the proper equipment, facilities, policies, and procedures, but it's up to you to take full advantage of these safety features. We'd like to encourage you to participate in our safety program and be your own ergonomics engineer. If you need assistance with any part of the safety program, or evaluation of your workstation, or just want more information about ergonomics, ask your supervisor. A team effort is required, and you're the most important part of the team. Thank you.